Happy Engineers Week! I'm Steve Watson, the Maricopa County School Superintendent here in Phoenix, Arizona, and I'm excited for today's panel. We have engineers from Boeing. And before I say anything else, I want to say thank you to these engineers and Boeing for taking the time to share their knowledge and their expertise and a little bit about their journey to inspire the next generation of engineers who are going to solve problems that we haven't even faced yet. And so I'm excited to hear from them. Let's check it out.
Good morning, and thank you for joining us for a special episode of STEM Pro Live. My name is Brian Hoffner, and I am here partnered up with two amazing professionals from Boeing. They're going to talk to us more about what it means to be an engineer and the fascinating work that they're doing. We also want to thank Boeing for their partnership during National Engineers Week as we're trying to introduce these career opportunities to all of our students that are here in Maricopa County, but also all the way across this nation, as we have students that are joining us from California and North Carolina and Alaska and all over the nation. So good morning. What I'm going to ask all of us to do is to use that chat box first and let me know where you're watching from so that I can kind of get a state roll call in here. And then as we're going through and we're talking to these engineers, if you have a question, use that Q&A box to pop that in there. And if you are a student using one of your teacher's logins, make sure you put that in the question so that I know which student it's coming from, so I can call you out by name. So I see those coming in from South Carolina, from Los Angeles, from the White Mountains, from Tempe, Arizona. That's awesome. So keep them coming. Love to know where you guys are watching from. So I want to start by introducing our panel and actually asking them to introduce themselves. So Natasha and Lydia, good morning.
Good morning, everyone. And good morning, Brian. Good morning, everyone who's tuning in. Just wanted to say thanks for coming, and we're really excited to talk to you all. Whether you're listening live after the fact, we really appreciate that you came to hear from us, and we hope that you get something out of it.
Nice. Good morning, Lydia. It looked like you were muted earlier. You good now?
I was. I'm good. Yeah. Should I go ahead and introduce myself?
Yes, please. Why don't you get us started?
All right. So my name is Lydia DePillis-Lindheim, and I work in Huntington Beach, California for the Boeing Company. So my job title is Systems Engineer. I'm an engineer that works with our unmanned autonomous submarines. So you can see from my background, there's this big thing behind me. This is one of our test platforms. It's called the Echo Voyager, and this is one of the things that we work on. So I'll pass it over to Natasha so you can introduce yourself too.
Hi, everyone. My name is Natasha Fernando. I'm a mechanical engineer at Boeing. I also work in our Maritime Undersea Division, working on underwater unmanned vehicles. What a mechanical engineer does is we combine physics, math, and material science concepts to create all kinds of machines and structures. And so what I create and work on is these vehicles.
Nice. So you guys are both working in this same program. Do you guys actually work on projects together?
We do.
Yes.
Yes.
Nice. So Lydia, you mentioned that you're a systems engineer. What is a systems engineer? What does a systems engineer do?
So my job, if you're familiar with the engineering design process, one of the very first things you have to do is define the problem or define the thing that you want to build. And that's where a systems engineer typically sits. So my job is to understand the requirements of what we're trying to accomplish and make sure that each of our teams know what role they play within that. So that's kind of at the very beginning of the cycle, but then it also fits in right at the end of the cycle where you have to be able to communicate what it is you've done and demonstrate that your product in the end actually accomplished what it was intended to do.
Nice. And Natasha, you're a mechanical engineer. So, and you talked about how that incorporates so many different disciplines, like the concepts in physics and math and chemistry and all that. But what does that actually mean in real time? Like, what is that?
Thank you, Brian. Yeah. So mechanical engineering, as I said, involves physics, math, material science. But at the end of the day, what you're trying to do is create a product that can stand up to different loads, different forces that are on it, You're trying to create something that, maybe a mechanism that serves a certain function. You're trying to make sure that a structure doesn't fall apart when it's in use. And your goal is to make sure that the product that you're creating can stand up to its full life cycle and do its intended purpose within the requirements that are given to you by, say, your systems engineers and your customer.
All right, so you made a couple comments in there that just popped a whole bunch of questions that I have. And students and teachers, if you have questions, please use our Q&A button down the bottom so we can incorporate those into the conversation. But the first thing you talked about was testing these things. So it made me think about the engineering design process that Lydia, you brought up earlier. And one of those steps is building a model. So as you're testing these things, that's kind of what I'm wondering is, are you building like a virtual model? Are you building like a computer simulation? Or are you building like a small scale? Or are you guys just going full into it to test the load to see if something is going to fail or if it's going to work?
So I'll jump in there. We do all of the above. We do use computer simulations because it's a lot cheaper to do something on your computer and find out that it's not going to work than it is to go buy a bunch of materials that you're going to use and then figure out down the road that something doesn't fit together. So it's definitely an iterative process. It's always good to use all the resources available to you. And with the technology that we have these days, computer simulations are a fantastic tool. But beyond that, we do actually have what we call prototype vehicles. So at some point, you do have to try it. And we build physical, real things that go and operate at sea. And in fact, the vehicle behind me is what we consider one of our test beds. So we use it to try out a whole bunch of things. Sometimes we break it a little bit, but then we fix it later. And we find out by learning what doesn't work, how to try other things and find out what does work. So do you want to add anything to that, Natasha?
Yeah, I'd love to. I think Lydia brought up a really important point, which is that we want to use all the resources that we have. It's very costly to take a real vehicle into the ocean and test it out. And we do that, but we like to go through a lot of things first to make sure that it will. So using some of the more like theoretical knowledge, we might make a computer-aided design model. So in CAD, we might make a 3D model of something. We might use a simulation software to apply forces to it in a computer program and run a simulation. And that can tell us, okay, well, this is really not going to work. And then you can maybe completely change your design. Once you get closer to your final design and you're fairly sure of its ability to work, that's when you can start testing it in real life. You might build some what's called test beds, where you maybe you have some sensor equipment and you hook it up to some computers instead of putting it into a real vehicle, and you test whether it'll work in a lab. And then once you've done all that lab testing, you can then, after you've built the vehicle, take it out to the ocean, and you know that a lot of things are much less likely to break, and you're fairly confident in your design. And of course, things are going to still break in the field, and it's those cycles of repeated failures and then overcoming those failures that is, it makes engineering really fun, and finding out what doesn't work, finding out what does work. So in your projects at home, if if you're making a design and it doesn't work out the way that you want it to, you're doing exactly what we do in our field every single day.
Yeah, and sometimes failure can be frustrating, right? I mean, we get really excited about our new plan and our design, and we think it's going to be awesome, and then something comes out of the blue and doesn't work, and that can take us by surprise. So it can be tough, but I think we should highlight that failure is a really important part of the engineering process, where we actually learn so much from it and we grow from failure. So it's important to embrace that.
So my son Jace, who's a first grader at Sierra Verde STEM School, he was actually yelling at me just last night because he was watching one of my broadcasts when I was talking to some engineers saying, most of us are afraid to fail. And we look for opportunities to put ourselves in a comfortable place so that we don't fail. And my son walks up, he's like, Mr. Lane would be so upset with you right now. And that's his STEM teacher. And he teaches 1st through 8th grade. And I'm like, why would he be upset? He's like, because he's excited when we fail, because that means we're learning. And I'm like, who are you? You're 7 years old. Go away. And so it was so amazing. And to hear you kind of co-signing on that, like, how do you guys approach problem solving? How do you approach this idea of it's kind of bound to fail sometimes?
Yeah, I think part of that process is knowing that you don't have all the answers yourself. For example, I'm a mechanical engineer, which means I don't know very much about electricity. I don't know very much about software bugs. I don't know everything in the systems engineering process. So I need to really rely on outside knowledge from other people who maybe they have some experience, maybe they failed before in the same area that I'm about to fail, and they can warn me before it happens. And I can say, oh, I didn't think about that. Let me take a look, and then you can gather some people who have more knowledge, have a meeting, and, try to tackle that problem before it bites you in the butt. And for me, it's all about learning to be okay with the fact that you don't know something and have this learning mindset that you're in it to find out what could happen. You're relying on your teammates who have strengths that you don't have. And, you're all going to tackle this problem together.
Absolutely. Yeah, it's a learning mindset. And one of the first things that we need to do when we fail is ask questions. So we usually start with what went wrong, and we want to make sure that we understand everything from top to bottom. And once we get that answered, then we start to ask why. And we don't just stop at one time. We ask why multiple times, because usually there's a chain reaction of events, and you want to get back to the root cause of what happened and what went wrong, and then grow and learn from there. So every time we learn, it's its own case study, it's its own learning opportunity, and it's very valuable to us.
So Natasha, you made a comment earlier that you'll take the information that somebody like a systems engineer like Lydia will produce, and then they'll work with it. So it sounds like you guys are constantly working in teams to do these types of things. And you were also talking about building these virtual models first. And we have a question that came in from Mr. Kemp's class. And Mr. Kemp's joining us from Charleston, South Carolina. He is a high school science teacher, a CTE teacher in the Charleston County. And they want to know, what platform do you guys use for your virtual trials? And is this something that you guys build, or do you guys have computer engineers that are helping build these pieces?
Thank you, Mr. Kemp's class, for that question. That's a really great question. So my experience is with things like stress analysis. So that is when you have a piece, say you have a bracket that is part of a structure, and you know that there are going to be forces on this structure, but you don't know whether or not the structure will be able to stand up to those forces, whether it will break or not. So a stress analyst on my team might take a software such as Siemens NX or SolidWorks. They use these software tools such as Nastran and Patran to take a closer look at those pieces, so they can simulate loads in the software. They can break the piece down into a smaller structure. They can do what's called meshing on a 3D part, where you simplify the geometry in a way that can be solved in a mathematical problem, and you can set a certain time limit on how much time you want to put into analyzing this piece, and then you can kind of let the computer do its thing and run and come back to it, and the computer will tell you this piece is going to be breaking at this load. Make sure you don't stress it out above this amount. And so we usually buy those softwares from other companies outside of us who specialize in creating those tools, and then we might have training within the company or other people who can teach us how to use it properly.
And I'll add on to that. So so our mechanical engineers use all of the different software tools that Natasha mentioned. We work in one area of Boeing. I know that engineers that work on our airplanes typically use CATIA for their 3D modeling, if you've heard of that one. But we do also use other types of software, something called Core, which we use to simulate what the vehicle does when it goes out on excursions. And that can model things like energy consumption so that we can understand how long we can go out on a mission. We do also have software that is custom built by our team of software engineers. And with that software, we have a lot of power to simulate what we actually want the vehicle to do. And so it's pretty amazing. They run a simulation, they'll say, here's what I want the vehicle to do. I want it to go to this place and to this depth. And at the end, you get a really cool map to show you what happened, when, where, and why. And you can adjust a lot of different knobs in that software to figure out if your plans will work in different scenarios. So really great question. The answer is yes, we use a whole lot of different software. Some of it is stuff that you can just purchase and you can practice using. Some of it is custom built secret sauce per se that we use within our company.
So I know that when we were talking with Tony Castella Jr. on Monday, he was talking about how all the virtual simulations that they create, and he was kind of talking to our students that love video games and these worlds and these realms that they're entering, these video games that you guys are using all the time as part of your simulations. And so if this is something that you're excited about, there might be opportunities there. We have a question that's coming in. It's from one of our second graders here in Arizona. It's from Miss Kruger's class, which I believe is out in Chandler. I think I lost, Gilbert, out in Gilbert. And she has a second grader named Zara who wants to know, what's the most important thing that you do? And I know that there's so many opportunities at Boeing and you have so many different projects you're on, but for you personally, what do you think is the most important part?
So I'll go ahead and answer that. Thanks for that question, Zara. It's a tough one. I feel like there are so many important things that we do, but at the core, I think the most important thing that we do is we work well in teams. And when you work well in teams, you can accomplish a lot because, as Natasha said, not every person can know everything, right? We can only remember so much. There's a lot that you guys are learning right now and you're soaking up all kinds of knowledge. And I'll bet you guys as second graders know some things that your parents might have forgotten at this point. So they might rely on you to remind them of those things. And that's the kind of thing that we have to do at work every day. I, as a systems engineer, I'm really good at remembering all of our requirements, but I don't necessarily remember how different pieces fit together inside the vehicle or where they're located. And so sometimes I have to call Natasha and ask her for help. And so we ask each other for help all the time. We work together, and no matter what the challenge is ahead of us, we work on it shoulder to shoulder, side by side, and we help each other to be successful. What would you say, Natasha?
Yeah, I 100% agree, Lydia, with the way that you respond to that. I think working in a team is the most important thing that we do. And it's what makes working at a company enjoyable is knowing that your team has your back, that they're going to support you, that you can go to them if you need help. And Zara, to answer your question from my perspective, I think that communication is really, really important because you communicate with your team all the time, constantly, all day. And so you need to tell them what you need. You need to tell them what's going on next. You have to communicate a lot of very specific, detailed information. And it's important that you do your best to get it right and that you help people as much as you can to understand what you're talking about. And so when we have miscommunications, that can cause problems. And I know that language is not something that you think about being a big part of engineering, but it ends up being a huge part of my job, especially being able to write things in a clear way and being able to talk about them in front of people.
So a lot of why we spend so much time here making these connections between industry and our classrooms is we want our kids to think about these opportunities right now. We want them to start to put these things into practice in their everyday life, because even if they don't plan on being an engineer, thinking like an engineer is a life skill that can help them in anything. And so we have one of our challenges this month that's around one of the programs that you guys are on. And so I'd like to show everyone in our audience that challenge, and then we'll come back and answer some quick questions about that.
Okay, students, we have a new challenge and need your solutions. This month's challenge has to do with exploration and navigation as we look at Boeing's underwater project to explore the oceans. Our office has partnered with engineers from Boeing to celebrate National Engineers Week. These professionals will join us live on Friday, February 26th at 10 a.m. to talk with students and teachers who take on this challenge.
Hi, I'm Lydia DePillis-Lindheim.
Hi, I'm Natasha Fernando.
We are engineers at Boeing, and we are excited to partner with schools across the country for National Engineering Week.
Natasha and Lydia are both engineers who work on developing, testing, and maintaining unmanned undersea vehicles. These vehicles are used for a variety of missions that were previously impossible due to limitations of underwater travel. To better understand, check out the extended reality experience that Boeing and Discovery Education have created. These allow students to imagine themselves underneath the planet's oceans and to see how science, technology, engineering, and math are allowing humans to explore, learn, and create in ways we never have before. Next, students can explore how to create a self-sustaining propulsion vessel and investigate designs that minimize environmental impact. The semi-autonomous propulsion activity focuses on design thinking and allows students to apply these learnings by creating and testing a self-propelling model boat. Design thinking is a process that engineers use when creating, developing, and testing solutions to tough problems.
All right, so the design thinking process applies at every level of our job. At the top level, it's really important with respect to what we're doing and why. It all starts with a customer, and that customer could be somebody who wants to learn more about the ocean floor. It could be one of our military customers or the government that wants to use our vehicles.
Your challenge this month is to think like an engineer at Boeing and research the challenges and obstacles with exploring and navigating the ocean floor. Then design a solution to modify the self-propelling model boat to solve a problem. We look forward to hearing from you about your ideas and solutions. Ocean exploration and navigation. Can you solve it?
All right, so the Echo Voyager, which is something you guys are doing in Huntington Beach, and I'm going to be looking for it when I come visit there this summer when I might be on vacation. We have a question that's coming in from Mr. Karam, and he wants to know if the Echo is currently being used in the ocean actively right now.
So at the moment, it is actually out of the water for maintenance. But in the last several years, we have been taking it into the ocean periodically to test it out. So it's actually the vehicle that you see behind Lydia's face. It is a semi-truck sized submarine. There are no people in it. There's no room for people. It's actually totally flooded. So there's no like large livable space inside that you would expect in a normal submarine. And so what we do is people on the field testing team will go live on a tugboat for several days, and they'll go out into the ocean, maybe off of Long Beach, like close to Catalina. And so we'll be running all these tests and seeing what the vehicle can do. So we'll come up with what's called a sortie plan, where you have a series of steps that you want the vehicle to take. So you may want it to dive to a certain depth. You may want it to go in circles. You may want it to recharge its batteries just to prove that it can. And so you'll have people that live on the boat that are looking at all the computers and sending signals to the vehicle to try and tell it what to do. You're going to have swimmers. So actually, Lydia and I are qualified to do this, where we actually are able to put on wetsuits and get into the water. Suppose you need to connect or disconnect the tow line to the boat, or you need to pull a pin or press a button or adjust something on the vehicle. That's what they would send us into the water to do. So it's a lot of fun. It is very unpredictable. You're prepared for something to go wrong at all times. And so a saying that we have on the field test team is, if you don't like the plan, just wait 15 minutes, because something always does go wrong. And it's just part of the fun of it. And part of the thing that makes our team so strong is being able to take these challenges as they come at us in real time. Emergencies always coming up, and being able to fix them and then troubleshoot and find a new solution. It's a lot of fun. Lydia, do you want to talk to that a little bit?
Yeah, actually, I'm really glad that you brought up what we get to do as part of the test team. I think that that's one of the coolest things about our job, frankly, is that we as engineers, usually we go into an office and that's where we do our work. We have desks and computers and we sit in conference rooms, but that's not what we do every day. So there are times where we get to go out and spend days at a time on the ocean working on our test platform. And like you said, those of us who are certified as swimmers aren't just on a boat on the ocean. Sometimes we actually get in the water with the vehicle and have to work with the crew to safely connect and disconnect lines, to do inspections and make sure that things are happening according to plan. And for me, that is just, it's so fun to be able to do something different. And I remember when I was doing my my training week to be one of the certified swimmers, and my thought was, I can't believe this is my job. I get paid to have fun and swim. And, it's not what I do every day, but it's one of the best parts. So I like that part about our program.
So we have one of our teachers that's in the Mesa Public Schools at Westwood High School, Mr. Reyes, and he's a world language teacher, but actually was taking on this challenge with his students. And the students are coming up with all kinds of questions for us. One of them was, what's the purpose of this submarine? But another question that somebody asked, and I'm not sure which student asked this, is this the first of its kind that you guys are working on? And how do you think this will change the engineering of boat technology?
That is a fantastic question. So the question was, is Echo Voyager the first of its kind? Yes, it is. It's a prototype vehicle. We've made other vehicles that are similar to it, but it is the first one of its particular size and design. And it was built so that we could test out concepts and capabilities for this platform. So for example, there are a lot of things that underwater vehicles can be used for, and the advantage of having something that's unmanned is that you don't need to put people in harm's way for a mission. The kind of depths that an unmanned underwater vehicle can go to are a lot deeper than what a diver could do. So for example, if you're trying to investigate a leak in an oil line that is way too deep for you to be able to actually dive to, or deep enough that it's dangerous to send someone, if you can send an unmanned underwater vehicle, you can potentially save lives or be safer. You can send all kinds of equipment down with the vehicle, such as sonar sensing technology. One really cool project that a previous vehicle did in partnership with NOAA, which is a government organization that was working with us. They sent us to go do an inspection and send back imagery, which was very detailed and three-dimensional, of a sunken U.S. warship. I think it was the USS Independence. And so they were able to send back a very detailed 3D image of a sunken ship that no one had been able to go down and look at because it was just too deep. And so we were able to recover a really cool piece of American history, which I'm really proud to have been on a program that did that. And there are all kinds of different applications that are still being explored, whether it's with regards to ocean exploration or defense applications, carrying payloads, transportation type things. Those are all being explored right now by the team that's testing Echo Voyager and by our team that's designing a new set of vehicles. It's a very
Great
exciting
answer,
So-
Natasha. Yeah, I think Natasha covered all of it. I don't know that I could add anything to that.
So we're gonna try to bring in one of our students right now. We haven't done this before, but one of our students, Vicente de Alba, who is a third grader, and let me scroll back up there. And yep, he's a third grader out at the Gilbert Public Schools, and he's actually the one that's featured in our video. And so if you see the students that are in there working there, he was actually building it, and he has a question for us. Can we go live to Vicente?
Yes.
Vicente, are you there?
Yeah.
Nice. Can you ask us what your question was?
I built a real model of a self-propelling device. Does the actual Voyager use the same technologies?
That's a great question. So the technology that we use on the Echo Voyager is a little bit different. Most of what it runs on is batteries, and those batteries have to be recharged. So we're not quite at a place where I would call it, perfectly environmentally friendly, because the way that we recharge those batteries does put exhaust into the air the same way that a car does, but it is a self-propelling vehicle. So we don't have anything connected to it. We don't have anything pushing it or pulling it. We have systems in place so that it's out on its own running, and it has the propulsion system to send it through the water. And it has what we call control surfaces, which are like fins. So you can imagine like fins on a dolphin to help it steer and turn and drive. So the idea is similar, but the technology is a little bit different.
Nice. And for those of you who haven't had an opportunity to take on that challenge, it really is a great way for your students to model that self-propelling content so that they can think about the applications of what are the opportunities if once this technology does revolutionize, what these things can do. We're running out of time, and I do want to kind of get to a final question for both of you, because we have so many students that are thinking about this type of career. And if nothing else, the work that you're doing and the type of work that you guys do carries across multiple different professions. And so what's something that you would suggest if you could talk to our audience and say, if this is a job you're thinking about, I would highly encourage you to do what?
Yeah, so this is something that Natasha and I talked about a little bit recently. And I think we were pretty much on the same page that one of the most important things that you can do as a student and as somebody who might be thinking about a career in STEM and really in anything is to ask a lot of questions. And sometimes we're hesitant to ask questions because we don't want people to know that we don't know all the answers and we don't want to look silly. But in fact, it's the opposite. So when you ask questions, it shows that you're curious, it shows that you're interested, that you want to learn, and it shows that you're really smart. So definitely think about all these problems, ask questions, and learn as much as you can. You want to add anything, Natasha?
Yeah, absolutely. I actually want to say that the fear of asking questions persists through people of all ages. I've seen it in college, in high school, and I see it in my workplace even now. I see that in some meetings, sometimes people don't want to ask something because they're afraid that everyone will know that they don't know the answer to it. But then they go ahead and ask the question, and everyone else in the room just breathes a sigh of relief because they were also afraid to ask the same question. And now that someone has finally answered it, they can breathe easy. And so it's really funny how many people have a fear of asking questions when they don't really need to. Anytime you don't know something, the worst that can happen is that you don't ask the question and then you never know the answer. And the best thing that you can do is ask the question. And even if you don't get a satisfying answer, it can kind of inform you on what questions to ask next. Asking questions means that you're learning. it means that you're growing. And so if you're interested in any field at all, I advise you to go talk to people who know more than you. Go find people that you can ask questions to and satisfy your curiosity so that you know what you are or aren't getting into. And when you do that, you can find opportunities, you can find new friends, you can find mentors and people who can help you out on your journey. So never stop learning and never stop asking these questions.
That is such great advice for all of our students. I'm so excited you guys were able to spend some time with us and be that role model for some of those kids that are out there thinking about this might be a job for them. So helping them expose, because when I think, or when I used to think of Boeing, I used to just think of airplanes. And so being exposed this week to so many of the different projects that you guys are part of, all the way from up in space down to the seafloor, is just fascinating. So thank you so much, ladies, for taking this time.
Thank you. Thanks for having us.
Thank you so much for having us. We're so happy to be here.
And thank you, students and teachers, for being a part of today's broadcast. If you're looking for any of these resources that we talked about, or you want to catch up on some of the other recordings that we did this week, you can find all those on our website. They'll also come out in an email later today for those of you who registered. So please feel free to forward that on to any of your colleagues. So ladies, thank you again. We really appreciate it. Thank you for joining us. We'll see you next month with STEM Pro Live. Thanks, everybody.